All right, welcome to section 6.4 part 1. We're going to finish this up today. What we're going to learn is how to transform graphs of log functions this time. Last section we did transformations of exponentials. Now we're going to do logs. And then we're going to learn how to write transformations of the graphs of logs and exponentials. Okay, so this page should look pretty similar to the last one. The transformations are exactly the same. The f of x notation is pretty much the same as well. Okay, so for the first one we're going to talk about is horizontal translations, and don't forget that that is left and right. And the function notation for horizontal translations is when we attach some h value to our x. Okay, and what do some of these examples look like for logs? So let's say we have log of x plus 4, and let's say we have log of x minus 7. Okay, so these two things do two totally different things. This one has a positive h, that's going to go to the left 4, and this one has a minus h, so this one's going to go to the right 7. Okay, so if you want to write this down again, a positive h moves left, a negative h moves right. Okay. All right, the second one is vertical translation again. So we have up and down. And the function notation for this one is we are going to add some k value or subtract some k value outside of the x, not attached to the x specifically. So for example, we have, let's see here, log of x plus 3. Or we have log of x minus 6. Okay, so those two things do two totally. So the first one, we have this plus 3, that's going to go up 3. And the minus 6 is going to go down 6. So if we want to write this, we have a positive k will go up, and we have negative k will go down. Okay, so that's all you have to remember for those. All right, so back to this, we have reflection again for the third one. And once again, we have x at a reflection over the x-axis, and we have a reflection over the y-axis. Okay, the x-axis function notation is we just make the x negative. Okay, for the y-axis, we make the whole function negative. Okay, so we take the whole function and then we add a negative to it. Okay, so an example of what each of these would look like. So for x-axis, we have log of negative x. And then for the y, we have negative log of x. Okay. So if you notice, we've just put a negative in front of the x part for the x-axis, and we make the whole function negative for the y-axis. Okay. So next one is horizontal stretch or shrink, which is the same thing as the last section. For this, we're going to multiply our x by some a value. Okay, we're going to multiply our x by some a value. So examples would be, let's see here. So we have log of 4x, and the second example could look like log of 1/2 x. Okay, so these are two different types. Okay, so the first one is a stretch. Let me get a different color here. This 4 here represents a stretch by 1/4. Okay, so that's a stretch. Oops, my fault. I made a mistake there. This is a shrink. Okay, whenever it's a whole number, you're going to say it is a shrink by the reciprocal. Okay, so it's a shrink by 1/4. When you have a fraction, okay, that is a stretch by the reciprocal. The reciprocal 1/2 is 2. Okay, so you have to remember for horizontal stretch and shrink, you have to use if it says shrink by 1/4, you have to use the reciprocal, which is 4. If it says stretch by 2, you have to use the reciprocal, which is 1/2. Okay, last one, we have vertical shrink or stretch. Okay, this one is when you take an a value and multiply the whole function by some a value. Okay, so our examples would be g of x equals 5 log of x, or g of x equals, let's see here, 2/3 log of x. Okay, so what do these represent? These are just whatever the number is. The first one would be, if it's a whole number bigger than 1, it is a stretch by 5. And the second one would be a shrink by 2/3. All right, so we got all of our transformations down. Let's run through some examples and see where we are at. All right, so it says state the transformation that g of x produces. Okay, so we have, in this first one here, we have log base 2 of x, so just a standard log problem. And this new one, we've attached this 3 to the outside. So when we attach a number to something, it's either going to be a vertical or it's going to be a horizontal. So let's figure out which one does the whole function by a number. Okay, so if we notice here, we have this function right here. It says a times your whole function. So when it is a whole number, it is a stretch by whatever that number is. Okay, so this one is a vertical stretch by 3, by a factor of 3. And we, as we can see this right here, okay, so this one right here is our original function. And if we notice here, our new one, okay, it's up higher now, so it's vertically stretching it. Okay, so if we notice, we have a vertical stretch here. It's getting longer. All right, so let's see example 2. Same thing. State the transformation that g of x produces. All right, so on the left here, f of x is equal to log base 1/4 of x. And if we notice here, now we have a 4 attached to the x, and we have a minus 5 to the outside. Okay, so let's do this minus 5 first. This right here is our k value. Okay, so if we go over back to a vertical, so if we have a plus or minus k after our function, it's up or down. Positive goes up, negative goes down. So let's see what this one is. Okay, so this one is a minus 5. So we're going to go down 5 units. Okay, and then now we need to see what this 4 attached to just the x was. On the last example, when you have a 3 by the whole function, it was a vertical stretch. Now we just have a number by the just attached to our x. So this one is going to be a horizontal. And remember, when you're talking about horizontal, you have to take the reciprocal. So instead of 4, we're going to use 1/4. So when it's a fraction, it is a shrink. Okay, so we're making it narrower by 1/4 of a unit. Okay. All right. So example 3, it says write an equation that reflects the graph over the x-axis and translate the graph 4 units to the right. Okay. All right, so let's see here. So I'm going to write the 2 part. And I know if I want to go right, we attach it to x, and it's actually going to be a negative. Okay. So in my exponent, I'm going to do minus 4. Okay, so that tells me when it's attached to the x, that's right or left. So there's my minus 4. Okay. And then lastly, we want to reflect over the x-axis. So that means we have to take the whole function and make it a negative. So I'm just going to put parentheses around it, and I'm going to make it a negative, and that will reflect us over the x-axis. And the minus 4 is going to make it move it 4 to the right. Okay. All right, example 4. Okay, it says write an equation that translates the graph 2 up and has a vertical stretch by a factor of 2. Okay. So let's see here. So log base 1/3 of x, and it says 2 up. So I'm going to put a plus 2 at the end of my equation, and that should help me move my whole function up 2. Okay. And then it says we have a vertical stretch by a factor of 2. And if we go back to the vertical stretch page, we have to multiply our whole function by some number. And whatever that number is, that's the number that we use in the problem. So it says by a factor of 2. So I'm going to take the whole function and I'm going to multiply it by 2. Now, you could probably leave it like this, but I'd ask you to take it one step further by doing your distribution. So 2 times log base 1/3 of x is just 2 log base 1/3 of x. And then we have plus 2 times 2, which is 4. So g of x equals 2 log base 1/3 of x plus 4 would be my equation. That will go up 2 and a vertical stretch by a factor of 2. Okay. And this one should be the last one. It says write an equation that translates 2 up and has a horizontal stretch by a factor of 3. Okay. So let's see here. We have 2 things we need to do here. So I'm going to write E. Oops. All right. So I'm going to write E, and it says it's going to go up 2. Okay. So it's going to go up 2. So plus 2. All right. And then we have to add something to our exponent here. It says we have a horizontal stretch by a factor of 3. And remember, when we're doing horizontal, you take the reciprocal. So the reciprocal of 3 is 1/3. So I need to create a little more space here. This is a negative x. So I'm going to keep the negative, and I'm going to add a 1/3 to my x. And this should actually be, it's a little typo there, that actually is a shrink. When you're dealing with a fraction, it is a shrink. Okay. All right. And that takes care of that. That's section 6.4 part 2. Sorry, another not so good error there. This is actually part 2. I apologize for that. So hopefully your notes will say that when you get them. I will see you tomorrow. We'll work more on these in class.